Next topic is the last topic of Unit 4, which is linear approximation. So this can come in handy if you don't have a calculator. You're never going to be asked this on a calculator section, I don't think. But this is essentially a way to find an approximate value of a function at a point that you can't really evaluate easily. So here we have cosine squared. We'll read the beginning in a second, but we have cosine squared of 3.5. Now, if we don't have a calculator, we have no way of knowing what cosine squared of 3.5 is. We can make a guess based on pi being 3.14 and 3.5 being a little higher than that. That's not going to give us a very accurate answer. So a better way to do this is linear approximation. So we can use the fact that a derivative approximates a function at a point. So here we have cosine squared of 7x, and we're looking for, so we're finding the linear approximation of this at x equals 0, then using that to find the value of the function at x equals 0.5. So we're trying to find this value around here. We're trying to find this without this graphing calculator. So what we can do, we can take the derivative of this function. So we have to use the chain rule a few times here. We have 2 cosine 7x, because the exponent comes down, times the derivative of cosine 7x. So then we have times negative sine 7x times derivative of 7x, which is 7. So now if we combine this all, we get negative 14 cosine 7x sine 7x. And we're looking, oh, and then derivative of x is just 1, so plus 1. And now we're looking for this at x equals 0. So the way to do this, you essentially find the tangent line, and then you use that tangent line as an approximation of the value at 0.5 in this case, but it'll make more sense once we do a problem. So here, if we plug in 0, this is the derivative at 0. We get cosine of 0 is 1, so negative 14 times 1 is negative 14. Then sine of 0 is just 0, so this whole thing just cancels out, and we're left with 1. So we get f prime of 0 equals 1. And now to find the slope of a tangent line here, we do y minus y1. So if we go to our function and our original function up here and plug in 0, 0 times 7 is 0, cosine of 0 is 1, 1 squared is just 1, plus x is 0, so we have 1 plus 0, which is 1. So our y value, I'll just write here, f of 0 equals 1. So our y value is 1, so we can do y minus y1, which is 1, equals our derivative, which is the slope of that line. We have here that it's 1, so we'll just leave it 1, and then it's at x equals 0, so x1 is 0, so it's just 1 times x, which is x. Then we get our tangent line as y equals x plus 1. So now to find the value at 0.5, which we know that because 7 times 0.5 is 3.5, and 0.5 times 1 is 0.5. So now we just plug in 0.5 right here, and we get 0.5 plus 1 equals 1.5. And that is our linear approximation to this not so linear function. And now if we look at our actual value, actually let's plot our tangent line to make this easier to see. So this is what we use to approximate. It doesn't look like a very good approximation in this case, but it actually does work out pretty well for us at this point. So at x equals 0.5 right here. Y is 1.377. So that's a pretty good approximation considering we didn't have to evaluate any crazy cosines. So our estimated value is up here, but our real value is really somewhere down here. So that's a pretty good estimate considering what we were given. And that's essentially linear approximation. So this won't be a whole, this will be a section of an FRQ at most, but it's still good to know in case in other cases in math you ever need to evaluate a cosine function without a calculator, you might want to use some linear approximation.